Hello and welcome to Colour Multimedia Enterprises. Now, that's weird. I looked through all of the menus to check to see if there was anything that was assigned to F12, and apparently, yeah, I am recording, and apparently something is assigned. It's to go to a function definition. If I right click, let's have a look. Yeah, it is F12. Huh. Alright then. Learn something new every day. But anyway, this video is in fact about learning, ironically. And I'm going to be continuing implementing further features to Twinspire and talking a little bit about the Codebase. So, what a lot of you probably don't know is how this code actually works. If you're one of those people who wishes to contribute to the project and you don't know where to start, well, I'm going to go through all of the code classes as they are currently, and what features I would like to implement in this free version of this particular editor. So let me get started by showing you the main form. So this is the main form. When you open up Twinspire from the GitHub page, which is here, if I just drag it over to my main window. So if you go over to the Twinspire page on GitHub, this is what you'll see. If you clone the GitHub repository and you click on the csproj file here, it should open in Visual Studio 2013 or later. Should do. There is no SLN file for this project. I could just add the SLN file, but I decided against it. So that's what you would need. Visual Studio 2013 or later. I use Visual Studio 2015 on my Windows 10 machine. So yeah, I'm just gonna move that back over here and go back into here. So when you open it, you'll be presented with this main form, this lovely main form. This is what it looks like. If you've used it before, then you should know exactly how it works, at least to a certain extent. You know that it does work, and that's the main thing. But if you're one of those people who wishes to contribute and help this project come along, then obviously you are going to need to know a bit about what's going on in this particular file. And it is the main form where most of the code actually works. So these are some initializations. I'll get into that a bit later. So I suppose the first things first is to scroll down to, yeah, let's start with this button click. So this is pretty simple. What's basically happening here is it's opening a folder browser dialog. So every time when you click on this button right here, it's doing this. It's getting the folder path for the My Documents folder on your Windows machine, and then it's going to show the dialog. If you click OK, then it's going to list the directory. And what it's going to do, if we go down to list directory, we pass in the tree view that we want to populate and the path. And then that path is going to be the path of what that selected path of the folder browser dialog is, as you can probably tell. So when you go through here, what we're doing is we're clearing all of the nodes for obvious reasons. We also want to get the current folder. The reason why we do that is because later on, when we come to executing commands from the command line, we are going to need to use that current folder path. So that current folder path is guessing the path up to and not including the folder that we up to and including the folder that we selected in the path. Ugh, Jesus Christ, I need to work on my talking. And then we do this check build config path. Now all this is if I just go to I need to not use that, yeah. Right, if I go to here, what we will do is we will take a look at file.exist. We're checking to see if the build.tsc file exists, which is what we explain in the I explain in the documentation. If it exists, then we are going to load that file and put it into that config that we initialized a bit earlier. And it's this configuration, this is the build configuration file. If there's any errors, it will display the error results inside, you guessed it, this here. So it'll post the message in the message column, or should do anyway. Still getting a few errors with that for some reason. So when we're populating the list, what we're doing is we're executing this static function here, create directory node, and we are getting some directory information specific to the path that we pass in. We get the directory information, we check to see if it's an actual directory. If it is, add that as an expandable directory. If it isn't, then we're going to check to see if it's a file. If it is, then we're going to check what the extension is. If the extension is any one of those that you can see currently, so .hx, we're basically specifying what image index it's going to be. The selected image index there and the image index here. So that's specifying which icons and indexes there are. And then we're adding those nodes and then returning the directory node, which then of course goes back into the tree view. And then we expand the very first node. So it's mostly self-explanatory. It shouldn't be too difficult to understand, and this is no longer needed. No longer using that. So we can get rid of that. Now, what I've also got is this refresh directory list. Now, every time the tree view is updated, i.e. you add a file or a folder, what is going to happen is this refresh directory list is going to be called. So what it's going to do is it's going to save the expansion state, which is going to get this thing, which is going to do this thing here. If I go into utilities and tree view extension, you don't really need to know this, but this is what's happening. Now I actually got this from code project. I haven't actually put a comment line here saying this code comes from code project at a given URL. I should probably do it now, actually thinking about it. So this class came from code project in aid of saving tree view states, expanding states, or expansion states perhaps, like that. Alright, so I'll update that in a moment. So what we do is begin update. For those of you who do not know what that does, basically it disables redrawing of the tree view as it says right there. So it basically disables redrawing. We relist a directory, so we call that function again that we specified a bit later. So that one there, earlier even. And then we set the expansion state and then end the update. So we redraw the surface of that control, and essentially everything is modified without any flickering nonsense going on. So that's all good. So let's go down to possibly some of the most important parts. So if we go to the console, we've got this. We've got two controls here. We've got txt results control, and we've also got txt console control. So if I go into here, just double click on that, and we've got this txt console key up, right? So here what's happening is when we press enter, we're going to identify exactly what's going to happen. So the current folder is equal to empty, then we're just going to return. Basically what that's saying is, if you haven't selected a folder, then it's simply not going to do anything. It's just not going to do anything. There's no point. Now, what we're also going to do is we're going to identify whether or not the text within the text console starts with a minus. If it is a minus, then we're going to execute the console command. Now this is where things start to get a bit more confusing, so I'll go into that in a bit. But if it doesn't, then we're just going to call it a start build. Now this, again, is not as confusing as the one that I'm about to mention. But what's going to happen is when we do that start build, we're going to check to see if the command is that, or the txt console.text is empty as well. If both of them are empty, we're going to return. Because the one thing that we don't want to do is when we hit enter in txt console and it's empty, and we just continue with the start build, but we'll end up with some errors along the way, and this is what's essentially going to happen. Both command is going to be empty and the txt console.text is empty. So what we end up with is a situation where both of them are empty and we're not actually passing in a parameter to be executed. This is the working directory for when we pass in the get command for getting the command process. All of this is drudge work basically. It's just clearing a few things. But apart from that, it's not really doing much. What we're doing here in the config, so we're checking to see if we're using the config or not, which by default is false. And the reason why we're doing that is because when we use the build configuration file and it has been parsed successfully, then what we're going to do is we're going to check to see if the libs property has a count that's greater than 0. If libs actually exists. If it does and it has a count greater than 0, then we are going to add the -lib command and put the name of that library into that command and then execute that command eventually once it gets to here. The idea behind that is if you have multiple build targets and you're using different libraries for each target but using the same code base, then you can sort of play around with which libraries you're going to be using, and you don't need to worry about obviously which targets you're going to be using. So all you would do in the console command is type -build followed by the target name that you're using. So you could have something like, okay, you're using link dialogues, for example, which only works on C++ for your OpenFL project, but because it only works in C++ and you also want to target HTML5, well, you're going to have a problem. So what you can do is you can have two targets set up in your configuration file. You could have a HTML5 target which does not include that library, and you can have different XML files that you can specify in that regard. I don't believe OpenFL complains if you pass in a different name of a XML file. It shouldn't do anyway, otherwise that would be kind of silly, but yeah. So anyway, moving on. So once we get that command process, we are going to start that command, because if we do not start it, it's not going to actually process within this process IO manager, which is possibly the most important class in this project. The reason why is because not only is it made by someone who actually knows what he's doing, unlike me, I know what I'm doing, but this is kind of a lifesaver, really. Without this class, I would not have been able to do things like monitoring the process in the background and being able to feed that back into the main form. So what this manager is essentially doing is it is going to run command prompts in the background and execute anything that you have put into as the arguments, if that makes any sense whatsoever. And if that is the case, then what we are going to do, if I just go out of this and go back into here, if it has any output or any errors, we are going to assign them those events, and we are going to start the process output read. So if that is the case, excuse me, if that is the case, what we are going to do is go to those events. So if I go to definition on std out read, what that is going to do is it's going to attempt to invoke put std out text, and we are going to assign that value. So if I go to put std out text, let's go to that definition. Oh, something else as well. Oh, it's at the top, isn't it? It should be at the top somewhere. Here we are. So if we're putting out the standard output, then we're just going to append the text to the txt results, which is this here. So if there's standard output, we're going to put the results into here. If there's standard error, we're going to parse the result that we get and put it into here. So if we go to here, we create an error result, which is defined at the bottom of this file. We are going to check to see if it starts with error, because sometimes it can start with that. Otherwise, if it doesn't contain that, but it does in fact contain a colon, then we can be sure that it is an error related to compiler error. And what we're going to do is we're going to parse that error. We're going to get a regular expression pattern to determine the difference between the error and the description, so the file, the line and the comment for that. We're going to get the file, which is the substring from index 0 up until the first colon. We're going to get the line number and then the message. If the text, when we receive it, does not match either of those, then we are just going to simply put that text into the error.message and add that error to standard error results. And then when we display the errors, if we go to that definition, we're going to clear the error results, which is this list view here. We're going to check to see if there are errors. So if there's errors within that list here, which we recently just populated, we are going to check to see if the file is equal to empty or not. If it isn't, we are going to add that file followed by the line and message. If not, we are going to pass in just the line and the message. Now, the reason for all of these empty parameters here is because I was trying to figure out exactly why the message wouldn't go under the message column. Sometimes it will actually go under the line column for some reason, and I really don't know why. Other times it will go under the message column. It really is very inconsistent. I really don't know why it's doing that, but apparently it does that. So yeah. So if we do go through the for each has errors is going to be equal to true, and if there is, then we're going to select that tab, and then we're going to say TXT console is enabled is equal to true. So that's how that works. Now, those are just hotkeys for those things, so it's not too much of a big deal. But if we go back to this key up here, and when we press enter, we have this console command, execute console command. Now this is probably the most confusing part of it all, because when we execute a console command, it is going to do loads and loads of functions, and those functions are probably going to be confusing to some people who wish to contribute to this project. The reason why is because if we go to the command class inside the utilities folder, we are going to see this execute command public static method here. And it is going to do a lot of things, and it's going to do all these function calls and more function calls, and it gets confusing very quick. So, as you can see, there is a lot of stuff here, and you're probably wondering, oh god, no, why? It's too many function calls. This is the reason why I do not like contributing to large projects, because the larger they become, the more difficult it becomes to learn exactly how everything works. And unless you do videos like I am, you're not going to get many contributors. It is as simple as that. So what I'm going to do is go to full lengths to make sure that if you wish to contribute, you know exactly what you're doing and know exactly what the code is doing, which is the reason why I'm making this video. So within the execute console command, we are going to do a few things. We're going to assign results to an empty string. We are going to get this args, which is going to be a list of string. We are going to have a current flag, which is going to be an empty string. We are also going to have a pattern. Now what we want to do is we are going to take this command, we are going to determine whether or not we have a series of commands that either starts with a dash or not, and we're going to split it into separate sort of flags, let's say. That's what I've called them, flags. Now what this speech mark pattern is doing is it is going to take a look at the result of this command, and it's going to split it on a space by space basis. Now if, for example, you have speech marks which has spaces in it, then those spaces are going to be ignored, and that is actually treated as one flag, if that makes sense. So if I just bring up Notepad, for example, so let's just bring a Notepad here, and if, for example, I passed into the console dash file src slash core slash something else, right? Build my file like that .hx hex class. Now what that would do when it gets through here, because I haven't included speech marks around starting from this src folder here all the way to here, it's going to treat this space as a separate flag. So my is a separate flag, file.hx is a separate flag, hex is a separate flag, and class is a separate flag. So when we're going into here, into this for each statement, and we're checking all the flags, we are going to get a count of, if we go back to Notepad, we are going to get a count of 1, 2, 3, 4, 5, 6 arguments. That is not good, and I was actually trying to find out exactly how to fix this until I managed to get the fix. So if I now wrap this into quotation marks, and it has to be double quotes, not single quotes, then that is now treated as a single flag, which means that the count is now 1, 2, 3, 4. So now the count for these matches is 4 instead of 6 or 7, whatever I said. So now it will actually work. So what we're doing is we're checking to see if the flag that we pass in starts with a dash. If it does, then we want to check to see if it contains a space. If it doesn't, we're going to remove that space and empty it out, because I haven't actually because the thing is, I've actually taken into account the space after the thing, so that's actually optional. It can be a space, but it doesn't have to be. If I remove that, it actually causes an error, I believe, or it might not do. I've never actually tried. Well, I sort of have tried it. I think it may have been because I did that, and that wasn't good. So let's not do that. But anyway, let's not go into that for the time being. But anyway, we are going. So when we see a dash, we are going to clear the arguments. We're going to set the command flag. So this set command flag, if we scroll down to here, and this is where things are going to get a bit confusing, and you're going to be like, oh my god, what's going on? So all we're really doing is we're saying, okay, we want to eventually tell the main form what we want to do once we feed back results from this console command, which is what this result string at the top is for. So when we go into this and we're setting all these command flags, right, the reason why we set those command flags is because eventually we are going to check to see what this is going to do. So this is basically telling the main form, okay, refresh the folder list. We are going to refresh the tree view list when we use the file command or the folder command. If we use the file command, we also want to open a new file, right? When we use the build command, we want to build the project. We are going to feed back those results to the main form, and we are going to build the project, right? So when we go to set command flag, we are going to check to see if that flag already exists, because we don't want to refresh the folder list so many times. We don't want to create a new file so many times, because obviously that will cause some errors. And obviously we don't want to build the project so many times, because that will again cause errors. So we want to check to see if that flag already exists. If it doesn't, then we are going to get that flag and add it to the results. And that's obviously splitting the results using that semicolon, because semicolon is what splits these up. So once we've done that, we are going to then go through each individual flag until we are done, right? So if it doesn't equal a minus in front of it, we know it is probably going to be a separate flag, and it is in fact going to be an argument for the given flag, right? If that makes sense. So we are going to check to see if it contains a speech mark. If it does, we're going to remove them, because otherwise we'll come up with errors later on when we execute the subcommand. Now the current flag, that's being assigned to this flag value here. The reason why is because when we go ahead and execute that subcommand, we are going to check to see if it starts with file, folder, or build. So what we're going to do, if it is file, we are going to check what the length is. If the length is 3, that means we are going to, that's the length of the arguments, by the way. So if we pass in, there's going to have to be one argument at least anyway, so that we can actually write the text of that argument to that given argument file. So what we're doing is we're checking to see if there is an index of a / in there. You can't do backslash, it has to be /. So if we go back to this example here, src / core / build my file, right? What we're doing is we're checking that path. So if we go to that definition, we're going to check to see if that path contains any one of those. If it does, we're going to check to see if the parent, the parent of this path exists. So we know that it's going to be a file. It's going to be here. We know it's going to be a file. So this is the path here. The file is the path that we're looking at. So when we get parent, we're checking to see if this core path exists. So we're checking to see if this part of the path exists from the current working directory, which is what that full folder path is. And if that doesn't exist, then we're going to create directory, which is going to create not only this if it doesn't exist, but also this if it doesn't exist. So it creates all directories, including any subdirectories, if that makes any sense. So that's what that's doing, and thus we are able to then, once we've done that, is create the file. If it contains Hakes and class as second arguments, for example, then we are going to not only write, we are not only going to write to that given document, which would be in this case build my file.hx. It is going to actually generate a class, which is going to be args0. So we're going to go into that Hakes class, which is in language readers, Hakes reader, generate class. I'm not using templates. You're probably wondering why. This is the reason why. So I'll get into that. So what we're doing is we're creating a string builder. If I'm going too fast, I do apologize. So what we're doing is we're getting the package. We're getting the package name from that name. So as you know, the args0, when we pass it in, where am I? Command. Args0, when we pass it in, is probably going to contain a / in there somewhere. So we need to check that, and we need to make sure that we take that into account. So that's why we have to do all of this stuff. If it also contains spaces, we are going to replace those spaces with an underscore. What we're also going to do is, when we check the class name, we also want to remove the .hx extension, because obviously that's not going to work. So we want to make sure that that class name, we replace any spaces with underscores. I am open to suggestions if it makes more sense that that isn't an underscore, then perhaps that could be changed. I'm not 100% sure. I haven't really programmed in Hakes enough to know that that is the best way to do it. But again, I'm open to suggestions. So what we're doing is we're appending the line. We're going to format a string which is going to get the package name, right? So if we go to here, which is a private static get package, we are going to check to see if the name starts with src / or source /. So assuming that the folder is either src or source, we are going to simply get rid of that. We're going to get rid of it. We don't need it. And then what we're going to do is we're going to get the package name from that source folder, and we're going to assign it to here. So essentially what's going to happen is when you generate this class in this file here, that is going to result in a package that says core like that. Not src like this. It's going to be like that, right? That's what that get package is doing. And when we generate the class, it's just going to do some default. So it's going to get the class name. It's going to get those things there. Oops, I wasn't meant to do that. Create the public function new, blah blah blah, and it's going to return a string. Same thing for the type def. Just going to generate a type def with a struct name. Just doing the same thing here, like that, with an equal sign, blah blah blah. Right. Pretty simple. And then if we go back to the command, we're just checking to see if it contains either class or td. If it's td, then we know it is a type def, right? Okay. Oh, excuse me once again, I do apologize. So if the argument length is only 1, so if we were to omit, if we go back to this example, if we were to omit those two, then the argument length is going to be 1. We're going to check that path once again, and we're just going to write an empty file. That's all we're going to do. Write an empty file, which means you would have to write it all yourself. But the reason why those arguments exist is to make life a bit easier. Now if we go down to folder, going to check to see if the argument's length is greater than 1. If it is, we're going to return. The reason why is because it is considered false. So essentially that's sort of safeguarding this this kind of behavior here. So if you're doing build my file like this, it's kind of safeguarding that, because we know that that's going to be considered more than one argument. That's this bit is one argument, the my is one argument, this is one argument, that is 3 arguments. So we need to put quotation marks around that. So if we were to have another folder which is core something like that, then we would safeguard against that. So just to make sure, obviously that would be folded like that. Otherwise we are going to create that directory using that first argument. And with the build command, all we're doing is we're getting the result, we're attaching the result of that argument back into the result. And then once we've done all of that, we are going to return that result, and that feeds back into here, which is in fact this result right here. Wow, we've got this far. We have got this far. So we're going to split those results, which is of course going to be a semicolon. We're going to get the refresh folder list. If it contains that, we're going to refresh directory list, which is that function that we saw earlier. Open new file. We're going to open a new file. We'll go into that in a bit. If it's build project, if a configuration file exists and it is parsed correctly, we are going to start the build using that configuration build command. Right. So when we pass in that argument, the second argument, right? If we go into here, if we do -build native, for example, and we have our configuration file that looks something like this, right? We always have a target that says native like that. And if we have a build command in here that says something like this, so build command like this, and you have hex-cpsrc -cpp build / and then dash main like that. What you would do, what that would do is when you do dash build native, it is going to go into this JSON formatted file. It's going to get that target and it's going to get that build command. It's going to retrieve it. It is going to go into this it's going to go into this process of execute console command. We get that one argument, we return that one argument because that's all we're really doing. Go to back to this main form. We know one of the arguments is going to be build project, so we get the second argument within that, right? If that makes sense. And we are going to check to see what that build is. We're going to start that build. We got conf back is equal to true. And if we did, we're going to just do I++ like that to go to the next splitted thing there. And then we're just going to continue on from there. Now, we know what that start build does. Saying we're using a configuration file and we're getting the index of that configuration. Okay, one last trip, which is to this open file here. So we'll check to see if that file exists. Going to go into each tab page here. If a tab page already exists with the current document path that we're passing in, then we're just going to go to that document by selecting that tab, right? That's all we're going to do. Otherwise, we are going to create a new document, which is this thing here, which is the editor class that we use to do all of the syntax highlighting. And it's nothing much. I mean, most of it's pretty much self-explanatory. If you want to learn how to create your own parsing language, then you can go ahead, and there is a link in the GitHub page that goes to that page for that fast colored text box. If we scroll down to shortcut keys here, it's this page right here, fast colored text box for syntax highlighting. This is what you can learn about it. This is the syntax highlighter that I'm most familiar with, so this is the reason why I'm using it. It's a good amount of information here, and here is the hotkeys for those of you who need to know. Okay, there's quite a lot of them, as you can see. But let's go back to here, go back into the main form. So we create that new document, we dock it, fill it up, assign some text changed things. We also get the key up event. We create a new tab page, get the short file name for that document, assign it to the text of that tab page, add the control of the document to that tab page, and then add the tab page to the main tabs, and then assign, and then set the selected tab to that one there. So that's all that's doing. Okay, I think that is everything. That is a lot of information and that took quite a while to do. So I'm going to leave it here. In the next video, what I'm going to do is I'm going to go through the next couple of features that I want to implement into this, because this is a long video already, so I'm just going to leave it for the time being. So thank you very much for watching. I hope you enjoyed, and I hope you understand now exactly how